Good morning, pre-calc. Today we are going to look at finding the trig values of any angle. Doesn't matter what the size is. There is a way we can do that. So if we choose any point, we can make a right triangle if we use the origin as one of the vertices for that right triangle. So keep in mind that the angle will always be on the x-axis. So if I wanted to pick this point 3, 4 and make a right triangle with it, I'm going to start at the origin. And I could go that route. Okay. That way my angle theta is right here on the x-axis. So your angle always comes out of the origin. That means the x value will always give the adjacent side of the triangle and the y will always be the opposite side. Okay, so here's the adjacent, here's the opposite. We can use a form of the Pythagorean theorem, which we've already done, to figure out what the hypotenuse is. So remember, we used hypotenuse squared equals opposite square plus adjacent square, something like that. And if we solve for h, we get the square root of adjacent squared plus opposite squared. Make that a square here. And since the adjacent side is always the x and the opposite side is always the y, we can substitute to get this formula. So if we want the hypotenuse, when we have to draw the triangle on the xy coordinate, we would use hypotenuse equals the square root of x squared plus y squared. That will always get us the hypotenuse length. And here's how it'll be used. We want to find the 6 trig values of the angle formed by the point 3, 4. Well, that means the adjacent side is going to be a length of 3, the opposite side is going to be a length of 4, and we have to plug those two values in to find h. 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. That is the square root of 25. So my hypotenuse should have a value of 5. I now have adjacent, opposite, and hypotenuse. I've got all three sides. All I have to do now is plug them into SOHCAHTOA. So sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse. Tangent is opposite over adjacent. And if I flip all three of those, I get the other three: cosecant, secant, and cotangent. So there's all my 6 trig function values for a triangle formed with the point 3, 4. So that point was in quadrant 1 of the coordinate plane, which everything is positive in that quadrant. But it's not the same in all the other quadrants. So when the point's in another quadrant, the sign of the trig values change. Here's a way to remember it. Each letter in these quadrants stands for one of the main trig functions, and that's the one that's always positive. So here's how we remember it. All students take calculus. Okay? All students take calculus. All of them are positive in quadrant 1. Sine and cosecant are positive in quadrant 2. Tangent and cotangent are positive in quadrant 3. And cosine and secant are positive in quadrant 4. So all students take calculus in a counterclockwise direction. That's how we remember what the signs of the trig functions are. All right, so there's another version of it. So let's see how we use it. We want to find the 6 trig ratios for the point -5, 4. If we graph and plot -5, 4, -5 this way, and 4 up, should be somewhere over here. Well, that's in quadrant 2. In quadrant 2, sine and cosecant are positive. All the others are negative. So we'll put the signs in last. Let's figure out my hypotenuse. Okay. This length is 5. This length is 4. That's the square root of 25 plus 16. That's the square root of 41. My hypotenuse is the square root of 41. Right? So sine is opposite over hypotenuse. And once we multiply by the conjugate and all that, we get 4 root 41 over 41. If we flip that, we get square root of 41 over 4. Cosine is adjacent over hypotenuse. 5 root 41 over 41. Remember, sine and cosecant are the positive ones. All the others are going to be negative. Secant is going to be negative root 41 over 5. Tangents opposite over adjacent. That's -4 over 5. Cotangent would be -5 over 4. All right. Here's the next one, -3, -6. That's down in quadrant 3. -3, -6, right here. So distance of 3 this way, distance of 6 this way. Need to find my hypotenuse. That's square root of 3 squared plus 6 squared. That's 3 root 5. So my hypotenuse is 3 root 5. So my adjacent is 3, my opposite is 6, my hypotenuse is 3 root 5. I can now find all the trig functions. Opposite over hypotenuse, multiply by the conjugate. And remember, in quadrant 3, tangent and cotangent are positive. All the other ones are negative. If I flip that, I get negative root 5 over 2. Cosine is adjacent over hypotenuse, so adjacent, negative 3, hypotenuse, 3 root 5. Multiply by the conjugate, I get negative root 5 over 5. If I flip cosine, I get secant, which is root 5 with a negative. Tangent, opposite over adjacent, that's 2 over 1, which is 2. Flip it, get 1 over 2. So tangent was opposite 6 divided by adjacent 3. We get 2. So again, tangent and cotangent are positive in quadrant 3. All the other trig functions will be negative. Next example, we have cosecant equals negative 5 over 3, and they tell us it's in quadrant 4. In quadrant 4, cosine and secant are positive. All the other ones are going to be negative. Cosecant is the reciprocal of sine, so it's hypotenuse over opposite. So if we plug those numbers in, 5 goes here, 3 is the opposite. We need to solve for adjacent. When we do that, we get 4. So it's a 3, 4, 5 triangle. But if you look on the graph, it's in a negative 4 position. So my sine is going to be 3 over 5. Cosine, 4 over 5. Tangent, 3 over 4. Remember the negative signs and the positive signs. In quadrant 4, cosine and secant are positive. All the others are negative. All right. Now we get to number 5, and it tells us that the cotangent of theta is undefined. Well, undefined means we're dividing by 0, and cosine equals 1. And this happens between 0 and pi over 2. Well, 0 and pi over 2, that's got to be quadrant 1. So everything's positive in quadrant 1. Cotangent is undefined. It tells us it could also happen in quadrant 4. Quadrant 1 or quadrant 4. They give us those domains. If cotangent is undefined, then tangent has to be 0. Because cotangent is a reciprocal of tangent. So if cotangent is undefined, it's some number divided by 0. And if we flip that, 0 is on top here. So that equals 0. That means the opposite side has to be 0. So that means this point has got to be on the axis. It's got to be on the axis. So therefore, if the opposite side is 0, that means sine is going to be 0 because that's opposite over hypotenuse. That's 0 over some number. That's 0. Cosecant would have to be reciprocal. It's undefined. Secant would have to be 1 because whatever numbers are left is going to be, secant is the reciprocal of cosine, so adjacent over hypotenuse, we flip it, we get hypotenuse over adjacent. They both have to be the same. Here we're going to name the quadrant the point is in. So remember, all students take calculus. Okay? Where is cosine positive? It's in 1 or 4. Cosine is positive in 1 and 4. Where is sine negative? Sine is negative. Well, it's not negative in 1. It should be negative in quadrant 4. Sine is negative in 3 and 4. So which one do you see in both? 4. So that point would have to be in quadrant 4. Where is secant negative and tangent negative? Well, tangent is negative. Well, it's not 1 or 2, so it has to be 3 or 4. All students take calculus. Tangent is negative in 2 and 4. Where is secant negative? Secant is related to which trig function? Cosine. So cosine and secant are positive in 1 and 4, so it has to be negative in 2 and 3. Okay. Negative in 2 and 3. Which one do you see in both? Quadrant 2. So that's going to be in quadrant 2. Let's talk about reference angles. Reference angle is the distance an angle is from the x-axis. Doesn't matter what quadrant you're in, how far is your angle, or how far is your distance of the angle from the x-axis. So you'd have to do different things in each of the 4 quadrants to find reference angles. So let's look at 80 degrees. If I drew an 80-degree angle, so that's like that. How far is that from the closest x-axis? Well, it's 80 degrees. Closest x-axis is the positive x-axis there. It's 80 degrees from there. (200 degrees). Let's draw a 200-degree angle. We're right about there. Where's the closest x-axis? Well, it's right here. Well, how far is that from the x-axis? We went 200 degrees. This is 180, so if we subtract them, it should be 20 degrees. The reference angle would be 20 degrees. (230 degrees). If we draw a 230-degree angle, we're right about here roughly. So 230. How far are we from the closest x-axis? Well, if we go back to this axis, we were at 180. 230 minus 180 would be 50 degrees. So 50 degrees would be the reference angle. (310 degrees). If we draw a 310-degree angle, that's about 30 to 40 degrees past 270. So that's 310. How far are we from the nearest x-axis? Well, the nearest x-axis is here. If I'm at 310, I'm going all the way around to 360. That reference angle is the difference between those two. That is 50 degrees. Pi over 6. We're in radians now. If I draw pi over 6, pi over 6 should be at what degree? If I multiply pi over 6 by 180 over pi, that's 180 divided by 6, that's 30 degrees. Pi over 6. What's my reference angle? Well, I am a distance of pi over 6 to the x-axis. Two pi over 3. 2 pi over 3. I multiply by 180 over pi, I get 2 times 180 divided by 3. 2 times 180 is 360 divided by 3. It's at 120 degrees. So if I draw a 120-degree angle, two pi over 3. This is pi out here. How close am I to the nearest x-axis? Well, I need to go to pi. What's pi minus 2 pi over 3? Well, that's pi over 3. The reference angle is pi over 3. Five pi over 4. If you want to convert it, five times 180 is 900 divided by 4. $225. So if I draw a 225-degree angle, here's 180, go another 45. So that's 5 pi over 4. How close is the nearest x-axis? Well, I've got to go back to the x-axis here to pi. So how far is that? Well, it's going to be pi over 4. Last one, 8 pi over 3. 8 divided by 3 is 2 2/3. So I'm going to be at the same place that 2/3 pi was. So my reference angle is going to be pi over 3. Reference angle pi over 3. Okay, that's today's lesson. Please stay on the Zoom if you have questions or need help going over problems. Have a good day.